Hi friends, I hope you're all doing great, prepping a lot for the D-Day which is going to come up. Many a times I have seen a lot of people having difficulty in understanding and then remembering the concepts of geometry, particularly circles. And hence in this part, we'll be summarizing all the key concepts and properties of circles in a brief video. So as far as circles concerned, some key definitions that we have to understand. When you have a circle, which is nothing but a locus of all the points equidistant from a given point, that point is called the center of the circle. If you have a center here and you have a line passing through the center, such a line is also called the diameter. From the center to the circle is called the radius. If you have any other line, any general line which connects 2 points on the circle, then such a line is called a chord. And if you, let's say, don't have a line here, let's say you have only 2 points here, A and B, then this curve is also called an arc. If you have 2 points A and B, there is a smaller arc and there is a bigger arc. The smaller arc will be called minor arc and the bigger arc will be called the major arc. If you join the points, let's say for an example, then it divides the circle into 2 parts. This is the bigger part and smaller part. The bigger part is called major segment and the smaller part is called minor segment. Apart from this, there is one more important aspect here. Let's say if you have a circle, from the center you draw 2 radius. Radius divides the circle into 2 parts, right? Into 2 pies basically. So this is one part of the pie, second part of the pie. Such part of the pie is called a sector. And how do you calculate the area of a sector? First off, area of the circle is given as pi r square and circumference is given as 2 pi r. Area of the sector will be, if let's say this angle is theta, by unitary method, theta upon 360 into pi r square. And what will be the circumference, or this arc length can be calculated again, theta upon 360 into 2 pi r. We've understood a few key concepts. Let's extend our discussion a little further. We understand what a chord is. A secant generally extends outside the circle also. It is also a type of chord. A secant also intersects the circle at 2 points and extends outside the chord as well. Diameter we already know. If we have a line which touches the circle at exactly 1 point, then such a line is called a tangent. If there are 2 circles that are sharing the same center but different radii, so if they have same center, radius here let's say 3, here let's say radius is 5, then such circles are called concentric circles. You can see an example here also. Now let's head straight into the key properties of circles. The first property says that the perpendicular from the center to the circle bisects the chord. So let's say you have a chord here and from the center you draw a perpendicular, then this line will bisect this chord. So AB will be divided into 2 equal halves. And the vice versa is also true. What does it mean? If I have a line here from center to this chord such that it bisects the chord, then it is also perpendicular to the chord. Second property, equal chords subtend equal angle at the center. So let's say if you have 2 chords, here let's say you have chord AB and here let's say you have chord CD. At the center, AB, let's say AB extends angle theta, CD extends angle alpha. If theta is equal to alpha, then AB is equal to CD. And vice versa is also true. What does it mean? If the chords are equal, if AB and CD are equal, then theta is also equal to alpha. What's the third property? Equal chords are equidistant from the center. So let's say I have a circle, I have 2 chords here, I have a chord AB and here I have a chord CD. From the center, perpendicular distance here, let's say this is X. Perpendicular distance here, let's say this is Y. Then if AB is equal to CD, then X is equal to Y. And the vice versa is also true, which means that if X is equal to Y or the distance from the center is same, then the chords are also equal. Fourth property, which is quite simple, if you have a circle and you have a tangent, tangent is always perpendicular to the radius at the point of contact. From any external point, there are only 2 tangents possible to a circle and both the tangents are equal in length. I hope this is clear to you. Next property, which is property 6. Angles inscribed in the same arc are equal. Quite interesting. Let's say if I have a circle here, I have an arc here AB. The arc AB, let's say, makes an angle ABC in this segment. If let's say it makes an angle ADB in the same segment, let's say makes an angle AEB again in the same segment, all these angles are equal. Always remember, has to be in the same segment. For example, if you draw this, there are two segments. This is the major segment, this is the minor segment. So all the angles in one segment will be equal. Okay, if I draw another angle, let's say here AFB, the angle AFB will not be equal to ACB, ADB, AEB. Let's say AGB, then AGB will be equal to AFB. I hope this is also clear. Equal arcs have equal chords. Let's say I have two arcs here AB, and if I have here another arc CD, so arc AB corresponds to chord AB and arc CD corresponds to chord CD. If these arcs are equal, the chords will also be equal, and vice versa. Eighth property, which is again very interesting, from arc AB on the center, if the angle is, let's say, 60, then the angle subtended on the periphery of the circle will be half of this angle, which is 30. So generally saying, if this is x, this angle is 2x. So a very important property here. If I have a circle and if I have a tangent here, at the point of contact, let's say if we have a chord here, let's say the chord is AB, the angle made by the tangent and the chord, let's say this angle x, is the same angle that the chord makes in the alternate segment. So this angle is also x. Remember, it's always the angle made in the alternate segment, not in this segment, but in the alternate segment. Similarly, let's say if this angle is y, angle made by this chord AC and the tangent is y, will be the same angle that the chord will make in not the same segment but the alternate segment. So this angle will be equal to y. So alternate segment theorem. Moving forward, opposite angles in a cyclic quadrilateral add up to 180. So if you have a circle here and let's say you have a quadrilateral here, this angle and this angle, x and y, will be supplementary, p and q will be supplementary. Property 11 is again very interesting, which is something which can be derived from something called a tangent secant theorem. So what's a tangent secant theorem? Let's see. Let's say that we have a tangent here which is PT, and let's say if we have a secant here PAB, then the tangent secant theorem says that PA into PB is equal to PT square. If I draw another secant here PCD, then PC into PD is also equal to PT square. So combining these, we can say PA into PB is equal to PC into PD, right? That is what is here. OB into OA is equal to OD into OC in this diagram. That's the same thing. Another important aspect is that whether this point is external to the circle or internal to the circle, this will always hold good. Another key property, last property, which is property 12, which talks about common tangents. When you have two circles and there are tangents common to it, such that these tangents are not intersecting, these are called direct tangents, and if the tangents are intersecting, they are called transverse tangents. If the distance between the centers is given as d and the radius is r1 here and r2 here, in that case the length of the tangent is given as root over d square minus r1 minus r2 whole square. That is for direct tangent, and for transverse it will become d square minus r1 plus r2 whole square. You can easily derive it also. You can draw a line here parallel, so then this becomes r1 minus r2, and you have this tangent which you have to calculate, and then you can calculate using Pythagoras theorem also. So derivation is quite easy, not a difficult thing, but remembering the property is very important. Another key bonus property before we wrap: if we have a circle and if we have a diameter here AB, then the angle in the semicircle must be 90 always. Important property, don't forget. Thank you so much. God bless you.